Integration page 9. So we're just continuing with doing indefinite integrals. So this one, we don't know how to do a product rule for integration, so we need to multiply it out. So it would expand using FOIL to 4x squared plus 4x plus 1. So when you take the integral of this, you end up with 4x cubed over 3 plus, and this would be 4x squared over 2, which would be 2x squared, and then plus x plus c. Wow, this one would be 2x divided by square root of x minus 1 over square root of x. Let's rewrite this. It would be 2 square root of x. I'm going to write it below. 2 square root of x minus x to the negative 1/2. So now we'll take the integral of each of these. So it'll be that, and I think that's right. Okay, just to make sure, we could take the take the derivatives of this. So if we took the derivative of this, it would be, let's see, 3/2 x to the 1/2, so that would be 2x to the 1/2, good. And then this would be, I think maybe this should be negative. Let's try that. So x to the 3/2, no, x to the 3/2, 2/3. I'm sorry, I'm taking the, I forgot. I'm taking the derivative, so x to the negative 1/2, negative. Okay. Yeah, I checked both of those, and they're fine. Now what about this one? This one, we don't do FOIL. We have to do like a Pascal's triangle expansion here, right? So these are our coefficients, and the first one's going to be x cubed, and the next one's going to be x squared, and the next one's going to be x, and they're all plus. Okay. And then we're going to take the integral of each one of those, x to the 4th over 4 plus x cubed over 3, and that cancels out with 3. And then it would be 3x squared over 2, and then the 1 would be plus x, and then plus c. Okay. Number 4a. So x to the 1/2, you take the integral of that, it would be 2/3 x to the 3/2. The integral of 1/2 cosine x would be 1/2 sine x plus c. And then the integral of 3 cosine t would be 3 sine of t. The integral of negative 1 over t would be negative log of t plus c. 5. Find y if the derivative of y is 6. So y would be 6x plus c. Let's rewrite this one. 5x to the 1/2 minus x squared. So they're basically asking for the integral if you're finding the y when dy dx is this. So the integral would be there we go, minus x cubed over 3. Plus c. This would be 2e to the x minus 5x plus c. Almost done with this page. Here again, we don't know product or quotient rule for integrals, so we need to multiply this out using FOIL. And then we just take the integral of that. It would be x minus 4x squared divided by 2, so 2x squared, plus 4x cubed over 3, plus c. Last one. So again, we don't know how to use product or quotient rule for integration, so we just divide it all out. So this will be 1 plus 2 over x minus 5 over x squared. So we could rewrite that as 1 plus 2x to the negative 1 minus 5x to the negative 2. So we'll get, if we take the integral of this, we're going to get x plus 2 over x is actually, the integral is 2 log of x, right? 5 over x to the negative 2, we're going to put x to the negative 1 plus 5, is that right? So like, take the derivative of that would be negative 5x to the negative 2. Yeah, that worked out. And then plus c. Okay, so that was it for page 9. See page 10. Find f of x if f dash of x equals that. So they're just asking us in another way of, to find the integral. So that would be x to the 4th over 4. And then the derivative, the integral of 5x to the 1/2 would be just x to the 3/2, 5 times 2/3, and plus 3x plus c. Now what about this one? 3e to the x minus 4 log x plus c. All right. When two derivatives are taken, then two integration constants are necessary. Two facts about the curve must be given to find these integration constants. Okay. So if they give us facts like this, extra facts, we can actually figure out what c is. Okay, so first we're going to figure out what the indefinite integral is. The indefinite integral will be 2x squared over 2 minus x plus c, right? Which is equal to x squared minus x plus c. So that is the integral. But they also tell us that if we put in 0, for x, then we're going to get a value of 3. So it will be 0 minus 0 plus c equals 3. So that means c is equal to 3. So it's actually equal to x squared minus x plus 3. Okay, so we can actually figure out what c is just because they gave us this one relationship between x and y. Let's do c. So the indefinite integral of that would be e to the x, and this would be x to the negative 1/2. So the integral would be 2x to the 1/2, I think. Yeah. Plus c. And then if we substitute in x equals 1, then we'll get that the function is equal to 1. So it's 1 equals e to the 1 plus 2 times 1 plus c. So c is equal to 1 minus 2 minus e. So it's equal to negative 1 minus e. So negative 1 plus e. That's equal to about negative 3.71, because remember e is 2.71, etc. Okay, number 2. Find f of x given that blah, blah, blah. Okay, so we're going to find the integral. The integral of f dash would be f, right? Going backwards from integrate derivatives. Would be this, right? You can, if you're not sure, go ahead and take the derivative. The derivative of x cubed over 3 is x squared. Derivative of negative 4 sine x is negative 4 cosine x. So it works, right? Then we're going to say, okay, what if x equals 0? 0 over 3 minus 4 sine 0. Remember, sine 0 is equal to 0. Set that equal to 3, oops, and plus c. So c is equal to 3. I forgot to put plus c there. Okay, so actually it's equal to x cubed over 3 minus 4 sine x plus 3. Last one, number 3. All right, find f of x given that, and this time they're giving us the second derivative, so we need to take two integrals. So the first integral is going to give us 2x squared plus x plus c1. And I can rewrite that. It's x squared plus x plus c1. And we know that if you put in, and this is f dashed of x, right? And we know that if we put in at 1 in for x, we're going to get 1 plus 1 plus c1. And we know that that's equal to 3, right? So that means that c1 is equal to 1. So now we can rewrite this. It's x squared plus x plus 1. And now we can take the integral of that, and then we're going to get the original function. So we're going to get x cubed over 3 plus x squared over 2 plus x plus c2. And now we use this relationship here. If x is 2, then we can set that whole thing at equal to 7. So 2 cubed is 8/3 plus 2 squared over 2 is 2 plus x equals 2 plus c2 is equal to 7. So now if we add these three up, it's going to be 4 plus 5, 6, 6 2/3. So if we subtract 6 2/3 from both sides, we're going to get 7 minus 6 2/3 is 1/3. So our C2 value is 1/3. Okay, so now we can rewrite our f of x. So now it's going to be x cubed of 3 plus x squared over 2 plus x plus 1/3. That's about f of x. Now let's do the same thing for this one here. So the second derivative of the function is cosine x. So the first derivative is going to be just sine x, right? Plus c, 1. And let's see, when x is pi over 2, then f dashed is going to be 0. So sine of pi over 2 is sine of 90 degrees, which happens to be 1. So it would be 1 plus c1 is equal to 0. So we know that c1 is equal to -1. So we'll rewrite f dash of x as sine of x minus 1. Then we're going to take the integral again to get the original function. It's going to be negative cosine x minus x. And let me just check if that's right. When I take the derivative of cosine x, I get negative sine x. So it's negative sine x. That's sine x. Derivative of negative x is -1. So that worked. I have to add the second integration constant, c2. Then I'm going to use this relationship here. If I put 0 in for the x, then I should set that equal to 3. So cosine of 0 is, cosine of 0 is 1. No, cosine of 0 is, cosine of 0 is 1. So it'd be -1 minus 0 plus c2 equals 3. So c2 is equal to 4. So we could rewrite this. We could write negative cosine x minus x plus 4. Okay, and that's it for page 10.